Right. Welcome back. Welcome back. Welcome back. Right. Let's continue with our question 2.4. Right. Now, at a certain stage of the motion, block Q breaks off. That part, it breaks off, just falls off. Okay. And falls down. How will each of the following be affected when this happens? Okay. Let's take note. Let's answer this together. The tension in the string choose increases, decreases, remains the same. What do you think will happen? Try to think of like this simple. If you were to hang, let's say I hang a baby on this string here, and then I hang an adult at this point on a string, which part will have the greatest tension? You'll agree with me, where you are hanging an adult, you'll have a great tension. In other words, sometimes if it is not a strong enough string, it might break, but it may be able to suspend a child. Okay, so the bigger the mass, then we're saying the bigger the tension. The smaller the mass, the less the tension. So if Q breaks off, there is a reduction in mass, and therefore we are going to have a reduction in tension. So we're saying our tension decreases. I hope that it makes some sense. Right. Now, what will happen to the velocity of the 20 kilogram block? And then we're saying, explain your answer. What will happen to the velocity? Remember, initially, this 20 kilogram block was moving to the right, right? And why is it moving to the right? It's because we're saying T is moving to the right, okay? And we're subtracting our friction. Remember, the friction is going to the left, and then we were also subtracting the component which we called our FAX, the horizontal component, okay, of that force going that side. So what do you think? If this T becomes more, what will happen? Okay, if these become bigger than the tension, it means this box might actually even change direction and start moving towards the left. Okay, because T is actually decreased. So we're saying as the tension force decreases, right? Are you taking note of that? The net force or your acceleration acts in the opposite direction. Okay, that is to the left. So it will start getting, these two forces will start to be greater than the tension, and therefore the net force will be to the left. Right. So this is quite an interesting section, our question 2, Newton's laws. And remember I said, when you look at these question 2s, ensure that you are covering all the aspects as dictated in your examination guideline, and you will not have any surprises. Okay. Right. Now, let us proceed to question 3. Right. Your question 3 focuses on vertical projectile motion. It's quite an interesting section. Right, and we're saying, what is expected of you? You should explain what is meant by a projectile. I hope you're taking down these things. What is meant by a projectile? Also, you should be able to use equations of motion. What are you using them for? To determine position, that is displacement, to determine velocity, okay, and also to determine the displacement of a projectile at any given time. These are the things that you should know for your question 3. Okay, let us proceed. What else? You should also be able to sketch graphs, okay, for position versus time, velocity versus time, and acceleration versus time. For what? For a free-falling object, okay, for an object that is thrown vertically. You see, I'm giving all these different scenarios because it is expected of you to know them. Any one of them can come up in the examination. Most probably not all of them, but any one of these situations can come up. And then also an object which is thrown vertically upwards, and also a bouncing objects. Okay, bouncing objects. You should be able to actually do them. Right. And then if you are given these graphs, displacement versus time, velocity versus time, acceleration versus time, you should be able to determine position, displacement, velocity, and acceleration at any given time. And we are guided by our CAPS document 102, 103. Those are the pages. Right. So take note, I said you get a question paper, you're preparing for your examination. Get to the question, identify which section that question actually lies. Go to your examination guideline. Look at other alternatives. Look for the different kinds of questions. You realize that at a particular year, there is a free falling body. At another year, you have got an object that is bouncing. So you need to be able to tackle questions from all these different sections. Right? I hope that is making sense. Right? Now, for us in this particular lesson, we're going to look at an object that bounces, right? This is quite an interesting question. And as usual, I want you to take note of these questions before we even attempt it. Define, you see? So define the term free fall. So you realize that each question has got a definition, definition. And those are 2 marks. So master your definitions and you'll earn yourselves 2 easy marks. Okay, so let's go through the question together and we see how we can tackle it. Right, so we're saying a small ball is dropped from a height of 2 meters. You can see this is the position versus time graph. Okay, so the ball starts there at 2 meters. Okay, and bounces a few times, landing on a cement. Okay, it bounces here, it bounces there, and then it stops there. Okay, now the position versus time graph is not drawn to scale. It represents the motion of the ball. Define the term free fall to max. Definitions, I don't want us to talk about them much. I need you to master your definitions, right? Then the second part, use the graph and determine. You understand? Application, are you able to use your graph to determine something? The time that the ball is in contact with the floor before the first bounce. Okay? The time it takes the ball to reach its maximum height after the first bounce. Right? I want you to look at these questions, right? 3.1, 3.21, and 3.22. Right? For these questions, I'm going to give you just 5 minutes. 5 minutes starting from now. Can you work on them? 5 minutes. Right, welcome back. Now, I cannot overemphasize the fact that you should know your definitions. These are free marks, guys. These are free marks, creators. So if you want to earn your free marks in the exam, ensure that you know the definitions is guided by the exam guideline. So internalize all those definitions. So the free fall, we know that this is the motion where we are saying the only force that we are having there is only the gravity. Okay, the only force acting on the object is gravity. All right, and then let's go to the next part. Now we are asked to calculate, use the graph to determine the time that the ball is in contact with the floor before the first bounce. So I want you to take note of something. When the object is falling, its position is decreasing. You can see with time, after 0.6 seconds, it is at 0 meters, 0 displacement. It is now in contact with the ground. But take note, that is the time it is in contact with the ground. From 0.64 to 0.67. That's how easy you get that information. It is still at 0. It means it's still in contact with the ground. So the time definitely is just going to be easy. It's going to be the final time, which is 0.67 minus 0.64. And what do you get? You get 0.03 seconds. As simply as that. So it means the time for the second bounce, you can go there again from 1.9 to 1.97. That is the time it is in contact with the ground. There is 0 displacement. I hope that makes sense. Okay, so you get your 2 free marks. Now, you are asked now the time it takes the ball to reach its maximum height after the first bounce, to reach its maximum height. So it's it's quite interesting. There are different approaches that you can actually use, right? But the easiest way, remember, we want to use the graph, okay? We just want to use the graph, all right? I want you to note something. The time it takes the ball to reach its maximum height after the first bounce. There it bounces. It's at 0.67. It comes and lands again. It's at what? Zero. It's at 1.90. Can you take note of that? Right. And where is it at its maximum height? It is at its maximum height at 1.85 meters. And what is that time? You're going to realize it is the time that is midway between 0.67 and 1.90. I hope you did not get lost there. It's easy because the time it takes to reach the maximum height is the same as the time it takes to come back to the ground. So half that time from 0.67 to 1.90, half that time is the time it takes to reach its maximum height. Okay, so how can we calculate it? You're going to say the final time is 1.90, all right, minus the time when it was moving from the ground going up. Okay, that gives you the time of flight from there to there. I hope it's making sense. And then we're saying half of that time, it is the time it took to reach its maximum height, which is 0.62 seconds. You see how easy it is. Ensure that you are able to interpret your graphs and you'll be earning your easy marks. Right, 3.23. Now we need the speed at which the ball leaves the floor at the first bounce. So it comes back. Okay, so we now need to know at what speed does it leave the floor from the first bounce. Okay, so now you're looking at your equations of motion. Which equation can you use? Okay, so remember, you need to look at the data that you have. All right, we need the initial velocity with which it actually leaves the floor. So we can use our equation. Final velocity is equal to initial velocity plus acceleration times time. Like, something I need to stress here about equations of motion. There are many ways of killing a cat. Do not be restricted. But I want you to choose the easiest and most efficient way for you to kill your cat. And how do you choose that method? You look at all your 4 equations of motion, right? Identify the variables that are provided for in your question. And look for the equation that has got a single unknown variable. That will make your life easy. Remember now, we need to get our initial velocity. So my formula, I'm saying final velocity, which is VF, is equal to initial velocity, VI, plus acceleration multiplied by delta T. I hope you know that by now, as I said, these equations should be at your fingertips. You should be playing with them, right? So what are we going to do? We're going to use, I want you to take note of how your questions are structured. 3.22, we're asked to calculate the time, that time, from there to there, which is the time to reach our maximum height. Did you note of that? So now, you have answered part 2. When you're asked to calculate this part, know that the solution that you get, you will use it to do your calculation in the next calculation. So we calculated that time, right? So what do I do now? For me to get my initial velocity there, which I'll call VI, when I'm moving from here going up, my initial velocity, I'm going to take note of the time to reach my maximum height. And what do I know? When I'm at the maximum height, what is my velocity? My velocity there, my final velocity is going to be what? It's going to be 0. Okay, because the ball is going to momentarily come to rest at its maximum height. So my final velocity is 0 because I'm at maximum height. My initial velocity, this is what I want to calculate. My acceleration, since I'm going up against gravity, we know that our acceleration is going to be negative 9.8 because g is going down, the object is slowing up as it goes up, right? And then our time, we calculated in 3.22 the time it takes from the first bounce to reach the maximum height is 0.62 seconds. Right. And then there you just a change of subject, the formula and whatever, all that kind of mathematics that you're doing, that's simple mathematics. And then remember your velocity there, you're going to get your velocity 6.08 meters per second. So 1 mark for your formula, 1 mark for your calculation, and the solution with the appropriate units, you get your 3 marks. But remember, as I said, there are many ways to kill a cat, and I'll advise you this is one of the easiest way. You can play around with some of the equations of motion, do the appropriate substitution, but this is the value that you are going to obtain. Right, let us proceed now to question 3.24. An interesting question, 6 marks there. Right, the time t indicated on the graph. So this is the time when our object now comes to stop. You need to calculate that time. And a small trick, a small reminder, remember I said, what you calculate on 3.23, see how you can use it on the next question. So you calculate a part, you may find that you need to apply that in the next calculation. Right, so I'll give you 6 minutes for you to attempt this question. 6 minutes. Right, welcome back, welcome back. So now we need to get the time there, and the question is, how are we going to get our time t? So the first thing that we are going to do, we'll agree that we're going to take the upward direction as positive, right? So it means when we're going down, we're going to be negative. And remember we said, first step, identify your variables, and then you choose the equation that you actually need. Right, so we're going to use the final velocity squared is equal to initial velocity squared plus 2a delta y. Okay? Okay, and we're here on the final section. We need to get this time. Okay, we need to get that time from 1.97 to t, right? When we get this time, we then add it to 1.97, and then we're able to actually get all the information that we need. I hope that is making sense. And take note, in the final bounds, we have got our displacement here, which is 1.2, okay, which we're calling our delta y. Right, so let's do our calculation here. So what we need to do now is to get the initial velocity with which this ball is going to bounce up with on the final bounce. What would be the initial velocity? Okay, so we're saying final velocity is going to be 0. Initial velocity, this is what we want to calculate. Okay, and then 2, our acceleration we know is negative 9.8, and then our height there is going to be what? 1.2. Right, so what are we going to obtain? We're going to obtain our VI, that is the initial velocity on the second bounce. Okay, and what are we going to get there? We're going to get our initial velocity of 4.85 meters per second. That is the first part. Right, now remember, when we have an initial velocity of 4.85, which formula now can we use to get our t? You're now playing with all your equations of motion. Remember, if my initial velocity here is 4.85, remember this is plus 4.85 because we said going upwards is positive. So it means when the ball reaches this side at time t, what will be the final velocity? Can you shout it out? What will be the final velocity? If my takeoff velocity here is equal to 4.85, positive, right? What will be my final velocity that side? It's going to be a negative 4.85. Upwards is positive, downward is what? Negative, right? So now I have VI, I have VF, okay? So what do I need to get? I need to get the time from there to there. And what else do I have? I have A. I know my A is a negative 9.8 meters per square second. So which is the simplest formula? Amongst the formulas that you have, all the ways they eventually lead to home. Understand? But choose the formula that will make life easy for you. And we're going to use final velocity is equal to initial velocity plus acceleration times time. Right? I've identified my variables. My final velocity is a negative 4.85. We agree, right? My initial velocity is a positive 4.85, right? My acceleration is a negative 9.8. I hope you got it. As I say, there are many ways to kill a cat. There are many ways to kill a cat. Explore the other equations of motion, right? And I guarantee you're going to actually get the same values, right? There may be slight differences, but there'll be permissible values, right? So there we can solve for delta t. Take note, this delta t that we're getting is that one, which is 0.9898 seconds from there to there. So what will be our t? It means our t is going to be the sum of 1.97 plus that time there. So we add them up together and we're going to get a total time of 2.96 seconds. That is our t, and you get 6 good marks. So these are the kind of questions that you are likely to face when it comes to your question 3. Right, let's go to the last but not least section for our lesson for today. That is our question 4. Right, now I'm not going to do what I did in question 2 and 3, letting you know which section we're dealing with. I want you to follow the stance that we used. Are you listening, grade 12? Identify the section. I hope you've identified the topic, right? For question 4, you go to your exam guideline. Take note of what is expected of you. You remember the first part, look at the first part of your questions. State the principle. If it's not saying state something, it's a definition. So I need you on question 4, understand the principles, the terms that you need to define. Write them somewhere, internalize them, so that you know your 2 marks are yours. Then the next is the application of the principles, use of your formulas to do your calculations, and then you're guaranteed of a very, very good pass. All right. So without wasting much time, let's go over the question. And as we were working, we'll continue the way we were working. I'll give you time to attempt some of the questions, and some of the questions we'll just straight away do together. Right. So I hope by now you've already identified which topic this is. All right. So we're saying a trolley X of mass 1.2 kilograms travels at 8 meters per second east. That is very, very important. So we're saying our east is positive. We can see from our graph there, it's a positive velocity, meaning our going to the east is positive, right? And collides with the trolley Y of mass 0.5 kilograms, right? Which is initially at rest. Oh, this is quite interesting. Ignore all frictional effects, and then we're told now the velocity time graph shows the velocity of the trolley X before, during, and after the collision with trolley Y. Right. So we're saying state the principle of conservation of linear momentum. I believe when you meet these questions now at this stage, you'll be smiling. Isn't it great? This is the time for you to laugh. As I said, you would have mastered the terms, all these principles. So these are 2 free marks, we agree. Then calculate. This is the interesting part which we need to do together, and we verify your calculations. All right? Calculate the velocity, what. Right. So let's start with the 4.1 together. Right. State the principle of conservation of linear momentum. That one is easy. We're saying in an isolated system, an isolated or closed system. That is a very important keyword. We need that to appear in your definition. In an isolated or closed system, the total, take note of that, the total linear momentum is conserved or remains constant. And then you get your 2 marks. I hope those key terms that I underlined are appearing in your statement. Right, let's go to the next part, the interesting part. Now, we read the whole question there. You are expected now to calculate the velocity of the trolley Y immediately after collision. So I'm going to give you 4 minutes for you to do that calculation. 4 minutes starting from now. Right, welcome back, guys. So let us do the calculation here. Remember, I said your questions are structured in a manner that they are related. So the first part, let's go back and I show you. State the principle of conservation linear momentum, right? The next part, calculate the velocity of the trolley Y. So now, it's now about the application of the principle. First part is the principle. Second part is the application. So how do we apply it? Let's look at that question. You see that the trolley X is traveling east, right, at 8 meters per second. This is our trolley. Let me just put the trolley there, right? It's traveling 8 meters per second. It's going to the east, and we're told this is positive from our graph. It is positive. And then we have a trolley Y. There is our Y. I'll put my Y there, and that is our X. Initially, our Y is at rest. So this is 0 meters per second. Okay, and we are told that your Y is 0.5 kilograms and your X is 1.2 kilograms. So this is the scenario that you have, right? And then they collide, right? And now you need the velocity of our Y after the collision. I hope that makes sense. So what we know when it comes to X, the velocity of X after collision, what will be the velocity of X after collision? I'm sure you got it. Yes, from your graph there, this is the collision part. What is the velocity? It's 4 meters per second. And you can see it's still positive, right? So it means it's still going east, but at a slower velocity, right? So we have the initial velocity for Y. What is the initial velocity of Y? It is at rest. So the initial velocity of Y, Vy, is actually 0 meters per second. I'm sure you were able to get that. So now let's apply our principle of conservation of linear momentum. What do we know when it comes to our principle of conservation of linear momentum? We know that the sum of our initial momentum before collision is equal to the sum of our momentum after collision. That is the final momentum, isn't it? So what is the initial momentum of our X? Initial momentum of our X. Remember, this is going to be mx, the mass of our X, multiplied by the initial velocity of X. I'll call it Vxi there, the initial velocity of our X. And we're saying we add that to the initial momentum of Y, which is the mass of our Y, right, multiplied by the velocity of Y, okay, the initial velocity of Y before collision. And then we're looking at the mass of X, right, multiplied by the velocity of X final, its final velocity after collision. I believe that is easy. And then the mass of Y multiplied by the final velocity of Y, let's call it, that's YF, okay? The final velocity of Y after collision. And now we know that from our analysis there, we can now put the values. All right, let's put the values there. What is the mass of X? The mass of X is 1.2 kilograms, And what is its initial velocity? We're told it's 8, a positive 8 meters per second. And then what is the mass of y? Okay, our mass of y, remember you're told is 0.5. Okay, and then what is the velocity of y? Its initial velocity, it is at rest, so its initial velocity 0, right? We go to what now? We go to the mass of x. It never changed, 1.2, right? Its velocity, final velocity, we said is 4 and still positive, right? It didn't change direction. It continued going east. I believe you also got that correct. And then the mass of y, 0.5, right? And then the velocity of y is the one that we need. The velocity of y, the final velocity of y after collision. Now already there you can see that you have an equation. Okay, you can solve for Vy there in our equation. Let's punch in the values into our calculators, and what are we getting? Vy, the Vy final is 9.6 meters per second. And take note, this is positive, right? It's a positive 9.6 meters per second. So it means this is going on. It's going to also the east. And then you get your marks. I'm sure that you were able to do that calculation, right? Let us proceed to the next part. Now you need to calculate the magnitude of the average net force that trolley X exerts on trolley Y during the collision. Average net force that trolley X exerts on trolley Y during the collision. Right. For that one, I'm going to give you 3 minutes. 3 minutes starting from now. Right, welcome back. So now let us look at the calculation together. So you need the average net force. X exerts on trolley Y during collision. So this is impulse, and you know the calculation. Important thing is the formulas. Go to your data sheet, identify the formula that you need, and we know that our F net delta T is equal to what? Our change in momentum. And now we can do our substitution. We know that our F net delta T is equal to what is change in momentum? It's mass, and we're saying it's the final velocity minus the initial velocity. Right, so we're looking at our trolley X, okay? So we know that is the initial velocity, right? And then that is our final velocity, all right? What do we know? We know the mass is 1.2 kilograms. We know that. And then our time we're given there was told that the average net force that the trolley X exerts on trolley Y during the collision. Right, what is our time? Our time, remember, you check your graph there. This is the time for your collision. Right, so what is your delta T? Your delta T is the final time, which is 20.02 minus the initial time. I hope you can take note of that and easily read your graphs. Minus 20.1. Right, so 20.2 minus 20.1, that gives us a 0.1 seconds. That is the time for our collision. Right, so the next thing you substitute. Right, an interesting part, we have always assuming to the east is positive, right? For interest's sake, now for this question, we're going to take the west is positive, right? So if the west is positive, what then becomes our calculation? All right, F net, I want you to take note of something. What is our time? Our time is 0.1, right? Right, and then what is our mass? Our mass is 1.2. Okay, what is our final velocity? Our final velocity is a 4 there, but it is going to the east, so it is going to be a -4 minus what is our initial velocity. Our initial velocity is an 8, which is positive, which is actually going to the east. Therefore, it's going to be a -8. I hope that makes sense. So your F net now is simply, you need to do your calculation there, 1,2 multiplied by -4 plus 8 divided by 0,1. And you do your calculation there and you put your value there in newtons. Right. I hope you found this calculation quite interesting. Right, guys, this brings us to the end of our lesson for today. Now, I'm not going to leave you empty-handed. Remember, we have covered questions 1 up to 4. Now, in our next lesson, we're going to continue the second part, questions 5 to question 8. And as such, I'm going to give you this homework, that is your question 5, for you to go over the questions and remember the steps I told you how to study in preparation for your examination. So I'm just going to give you a few seconds for you to just take a snapshot of the questions there. Just take a snapshot of these questions, just a few seconds. Right? And also the second part of your homework, you can take another snapshot. Right, I believe you're done there taking the snapshot. Right, guys, otherwise, that being said, I hope you found the lesson quite informative. Till we meet again, may God bless you.